Hey, you're back, and that means you must continue wanting to play play chess, or learn how to play chess, or learn not even learn how to play it, learn how to make it with Ruby. So what we did last time, we set up our board. We sort of got something rendering with a really basic class that's called board renderer text. That's for like rendering it out in text. What we're gonna do now is actually figure out how we can decide whether or not a piece can move. So what I wanted to do was just talk about, like, if a piece, what are all the different possible moves that a piece can make given its position. And so before, when we started this, we initialized all of our pieces with a color, right? And so we have a bishop, and we have a king and a knight and a pawn, and all of these have one single initialize method that right now is just taking in the color. Similarly, we have an adder reader. These lines here at the top are actually the same across every single piece. And so what I wanted to do was talk about inheritance today. And so it turns out that if you have a bunch of classes that are all sort of the same type, and they all share similar logic, but need to differ based on they need to differ in some subtle way, then you might want to use inheritance. Now, typically you want to prefer composition over inheritance, meaning that it's better to like pass in things to change or to use like standard logic. In this case though, we want to set up all of our pieces the same exact way. So what I want to do is create a new file called piece.rb, and this is going to be the parent class. This is going to be like the top level piece that all other pieces will inherit from. So we're going to create a class. Again, this is sort of a blueprint. And this will be the class that all other pieces inherit from. So all pieces will now just have, instead of having this kind of like code inside of the logic for the class, the individual class, instead what we're going to do is we're going to inherit from piece. And the way we do inheritance in Ruby is right after the class name, we put this less than sign and then the name of the parent class. So now we have a class pawn that inherits from piece. Now, knight is going to be different than pawn because knight is going to have a different symbol for its string value. We could actually simplify this potentially a little bit and just say like def sim or something like that had the symbol, and then we could like change the color and print it out in a different way. But for now, we'll just keep it like this so that each method defines its own 2s and its own move directions, which we'll continue using. And then instead we'll go to each of these pieces and we'll make sure that they inherit from piece. And now we can safely remove that code that's at the top there. So we want a king to also inherit from piece, and we can remove this code that's at the top here. A knight is also going to inherit from piece. And we're going to remove this stuff from the top. A piece, nope. Pawn, good. Queen, similarly, it's going to inherit from piece. What this makes it easier to do also is that if we, as we go down the road, if we want to initialize all of these pieces the same way, we only have to change it in one spot. And we're actually we're gonna do that here in a moment. All right, so then rook also needs to inherit from piece, not double, just one. Okay, I think we're back to a good spot where each piece now just has its toString method, and it has this move directions method. Now in piece, what I think we want to do is start to figure out how to decide what are all the different available and possible and total moves that a given piece can make. So we have the directions that a piece can move. So for instance, a king can move in all 8 directions around itself, but that's technically not really true if the king is in the starting position and it has ally pieces all around it. So one thing that we need to do, I think, is from the piece class, is in addition to the color, I think we also want to pass in reference to the board and to the position of the piece. So let's start out by passing in the board. And so we'll say every piece now has reference to the board. and we can make that also an attr reader. Okay, and then similarly, what we want to do is we want a method that checks to see if a piece at another position is an enemy piece, and then, or if like the position is empty. So let's say like on the piece class, maybe we can ask like if a piece is an enemy. So if a piece at a given position is an enemy. So let's say we'll pass in the location here, and we can say, is the piece at that location an enemy? So we want to say board at location. So is the piece at that location nil? Or is the board at that location, is the color of that piece equal to my color? This should tell us whether or not a piece is an enemy piece. Now this is where it gets really helpful in our main function to be able to initialize a board without actually setting up all the pieces on it. So here what we can do is we can say board.new, and then we can set up just a couple pieces. So we can say board at 0, 0 is going to be pawn.new, and we'll pass in the reference to the board, and then we'll also pass in the color, black, and then we'll put a piece right next to it on the board at 0, 1, and we'll say that this one is white. Okay, now what we should be able to do is ask if this pawn, so the pawn that's at this position, so piece is, oops. So the piece that's at position 0, 0, so this pawn right here, if we ask it piece.enemy of 0, 1, we expect that this is going to give us back true. So we'll comment this out. Because the piece at that position is white, it's not black, and so it should be an enemy. So we're going to say run. Require relative bishop uninitialized constant piece. So we haven't actually imported the piece. The other thing I wanted to do was, like, instead of having to like import all of these, eventually importing just the piece. Yeah. So let's import pieces. So let's make a new class here called pieces.rb, and it will be purely responsible for importing all the pieces. So we'll go back to main. No. Let's go to board, and then we'll cut this and put it in pieces, and then we'll just require all the pieces this way. And we want to require the piece first. Require piece, just so that they're loaded in the right order. So now in main, we should be able to just require pieces. And then the board, I think this might work. I don't know, let's see. False. Puts enemy at that position is false. Why is it false? Piece.enemy. So piece.enemy. Is the location nil, or does the location, does it not equal our color? I think we actually just want it to be not nil. We want it to be not nil and not our color. Because if it's a nil location, then it's not an enemy technically. It is just an empty spot. And true. Okay, so that is an enemy. And then if we go back to our main and we say, is the piece an enemy at position 0, 0? And it should not be, because that's our self. So we should see true and then false here. True and false, and we do. Okay, so that is great. We are able to check to see if a piece at another location is an enemy. All right, the next piece, or the next thing that we want to do here is figure out how we can move the pieces around. So when we're looking back at this board, and let's actually put this at 0, 1, and let's check to see let's actually do 0, 0, and let's put a rook. And what we want to start figuring out is the available moves for a piece. So let's say dot available moves, which doesn't exist yet. So let's go implement this method on the rook class. So let's go to rook. So we have our move directions, and now we want to figure out how to implement available moves, which I think is, nope. This is not responding very quickly. I don't know what's up. Okay, so the available moves are going to be, we want to iterate over the move directions that we can go in. And we want to see like, for a rook in particular, like a rook can slide. So a rook can slide up to a piece of its own color, or it can slide up to and including one more square if it's an enemy piece to like take that piece, right? So what we want to do is we want to iterate over the directions that we can move in. So move dirs.each do, I guess this is going to be like dx, dy or something like that, dr, dc. So that's kind of like the diff in the row and the diff in the column. And then we want to check, like we sort of want to build up an array of possible sort of positions that we could move to for this piece. So I'm just going to say moves is equal to an empty array, and this is what we're going to return from this method also, is a list of moves. Now what we want to do is say like, okay, now that we have the directions, we need to build based on our current position. So we do need our position. So the current piece doesn't actually have reference to its own position yet. We have the board, we have the color. I had a hunch that we would also need our position. So let's say location, and let's store this as at location is location, and we'll say location. Okay, so when we initialize a piece, we need to pass in the board and its location. So we need to go back even further to our board class and update this start chess thing to pass in all the right instance methods. But for now, we can just keep messing around with this here. And where did we make it? We made it the second argument, or the, second argument. So back in main. So the second argument here is going to be 0, 0. So technically we have the state of where the piece is on the board. We are storing that in two spots. We're storing it on the piece itself and also on the board. So it's kind of like duplicating that, but it'll be helpful inside of the rook class when we try to decide what our available moves are. Let's go back over to rook. Now that we have position, we want to start at our given position and sort of grow in the direction that we want to move, or like start sliding in that direction to see where we hit some boundary. So if it's almost like we actually need to loop here. So loop. So what are we going to do? We're going to say like until we hit a piece, we want to like add the location of, or add the location plus dr dc to moves. Okay, so we have the move direction and we have our current position. So if our current position is 0, 0, then we want, and our move direction here, our first one is 0, 1. Then what we want to do is we want to add 0, 0 plus 0, 1. So then we're going to end up with 0, 1. And if this position ends up being empty, or an enemy, then we want to add it into the list of moves. So how do we get this? We're going to need to destructure like our current R and current C. So the current row and current column is destructured from self.location. And what we want to do, that's where our starting point is going to be, is current R and current C. So we're going to say for every direction that we can move in, we're going to say current R plus dr, comma, current C plus dc. That's going to be like the new possible location in that one direction, right? And we want to keep incrementing in that direction until we, until we end up. Okay, so I think we actually want to grab this location every time we're considering a new direction, because we want to like reset back at the current location. So we're at the current location, and now we want to start doing our loop. So loop, or like while or something, loop, let's just do loop do, and then end. Okay, and so what we're going to do is we're going to say that the current R, current C is equal to, or actually we can just do like current R plus equals dr, current C plus equals dc. So that should give us like an updated position. And then we want to say like if this is empty on the board, so if board.empty at this location, or well, yeah, let's just start with empty. So if the board is empty at that location, we want to add that location to moves, and we want to keep going. So moves, we want to shovel in location. So this shovel operator is the same as saying moves.push and or .push loc, and that adds this array to this this array of arrays. So moves, we're going to shovel in location. Okay, so we're going to keep looping and we're going to keep going in this direction. If the board is empty at that location, we're going to add it to moves. If we're not in range of the board, we should break. So if so let's say let's see here. So we want to break if. So break is how we get out of this loop here. So loop do is just going to keep looping forever. It's kind of like while true. So break, and when we call break here, it should only break out of this loop and bring us back to this each. So we want to break if the location is off the board. So if board.inRange location, right? Because we wrote that method in the first episode, in range. So or in bounds, we have as this method down here. Okay, so if we're not in bounds, if the location is not in bounds, then we want to break the loop. What are some other cases that we might want to break the loop? Well, if the board is empty, we just want to shovel on there. If the board.enemy, if it's an enemy at that location, or I guess we implemented enemy on piece directly. So we can say, if it's an enemy at that location, then we do want to add that to our list of moves, but we also want to break after we do so that we don't keep going and like attacking all the enemies. So then we want to break here. So this is a little bit confusing, but basically what we're doing is we're saying that for each direction that we can go in, for all these 4 directions, what we want to do is take our current location, so reset back to where we are now, and then we want to iterate or sort of slide. This is the part that's actually sliding in a certain direction. And we want to take our current row and our current column, and we want to increase them by our direction. So in some cases, we're actually going to be going backwards, right? So if we do plus equals with the -1, that's going to be going down. So we're going to increase them by that direction, and that'll give us a new location. And if the new location is not in bounds, then we're done and we want to break out. If the location is empty, we want to add it to moves. So let's do that as like a postfix thing here. Whatever, we'll keep it fixed. Okay, and then otherwise, if there's an enemy at that location, then we do want to add that one location to moves, but then we want to break out and go consider another direction. And then if we get to the end of all the directions, then we should have a list of moves that we should be able to spit out here. So let's go take a look at Rook's available moves. I don't know, maybe this will work. We'll see. So if we run this, it fails. Undefined method empty. Oh gosh, we didn't write an empty method on the board. So let's make a method empty at location, and we'll just say like if grid at row column is equal to location. If the grid at that row and column is nil, then it's empty. We don't have a null object yet, or a null object pattern yet. So for now, it's just going to show as empty. Oh, and we're probably not. Oh, we didn't print it out yet. So let's do p. Yeah. So let's actually clear this and see if that'll help us. All right, run. All right. So is this the actual possible moves? If we have a rook that's at 0, 0, we can move up 1. We can have 2, 3, 4, 5, 6, 7. And then we can also move to the right all the way to the end. Good. This is great. So now if we put the rook in a different spot, let's say we put the rook on like 2, 2. So we say 2, 2, and then we grab the rook at that position. Then we should get different numbers here. Okay, great. So 2, 3, 2, 4, 2, 5. 2, 6, 2, 7, and then also backwards 2, 1, 2, 0. Okay, I think this is totally working. And so this available moves method here that we've written will work for every piece that can slide. This will work for every piece that can slide. So what are the pieces that can slide? We've got rook, bishop, and queen, I believe, are all pieces that can slide. So what we want to do is, rather than keep this logic in the rook class directly, we're going to break this out. And if we wanted to like include some sort of logic in just a handful of classes, we don't really want to move this into piece, because the available moves for, say, a king, like a king is not a sliding piece. So a king should not be able to just loop over all the possible directions and keep moving in that direction. And so what I wanted to do now was introduce the concept of a module. So a module in Ruby is similar to a class where you cannot actually instantiate an instance of it. Instead, it is just a bag of logic, or like a bag of functions that you want to like attach to something, or some like set of logic that you want to include or extend a class with. So in Ruby, it's conventional to name your modules with the able or like ibble suffix. So in this case, let's call it slideable.rb, slideable. And instead of calling it with a class, we say module slideable. And in here, this is where we're going to move our method for available moves. So let's put this into slideable. Okay. So now slideable has the actual available moves. And if we go back to rook, we can clean this up and say, the way that we like move the slideable modules code, so the way that we make this method available inside of rook is we say include slideable. So this is how we extend or add logic to the rook class with instance methods. If we wanted to add them as class methods, we can use extend. I might be misremembering that. Let's see, module extend versus include in Ruby. Yeah, okay, so that's right. Okay, so extend does import them as class methods. Include includes them as instance methods. Honestly, I've almost always used include. In Rails, there's this thing called an active record concern, or a concern in Rails. And concerns have ways that you can add things as both class and instance methods with like the special class methods thing. But for now, just know that like it's common to include something if you want to add the methods from that module as instance methods. All right, very cool. So now what we can do is just copy this slideable thing and add it to queen. And boom, we've got a slideable queen. Same thing with bishop, right? So now we've got a slideable bishop. All right, so that is how we're going to implement the slideable module. Now let's talk about some pieces that only step. So maybe let's talk about the king, for instance. So we want to name the method exactly the same, and we want it to like act or behave pretty similarly. So let's actually copy the entire thing And let's actually just off the bat, we'll create a new method and we'll call it stepable.rb. And this will be a module stepable. And it is all about stepping. So instead of looping here, I think what we want to do is just remove the loop. And is that all we need to do? Let's see. All right, so let's think through this. So we have all the move directions. For a king, it's all 8 directions around. And we're gonna start at the current location. And then we are going to create a new location that has the change in direction. And that's our new location. And if it's not in bounds, we want to break. Oh, we don't really want to break. We don't want to break, but it has to be in bounds if we're going to add it. So let's do, I think we can do next, which should go to the next part of the loop. So we can do next if the board is not in bounds. If it's an enemy at that location, then we do want to add it. And if it's empty, if it's empty, we do want to add it. If it's an enemy, we do want to add it. We don't need this break anymore. And we can actually simplify this just a little bit because I think we can say if it's empty or it's an enemy, then we want to add it to the location. And I think we might even be able to just say like, if it's in bounds, and it's either empty or an enemy, then we add it to the location. Okay, so the conditional there was getting a little complicated, and this is actually a little bit more clear when you're reading it, so I'm gonna keep it simple like that. All right, let's go check it out. So we've got stepable. We need to include stepable in king. Say include stepable. And then let's go back to our main class. All right, so then here we can say king, and the same logic should apply. So we should be able to just say go for it and see the pieces. Uninitialized constant bishop slideable. Ah, yes. So in our pieces here, let's import the modules at the very top. So we can say slideable and stepable. And then let's run. Slideable. Okay, cool. So we've got some results. So from 2-2, we should be able to move to 2-3 or 3-3 or 3-2 or 2-1 or 3-1 or 1-3 or 1-1. Okay, I think 1, 2, 3, 4, 5, 6, 7, 8. Great. I think that's good. And then if we go to 0-0, right, like we should not be able to move into the like negative space. So I think this should only give us 1, 2, 3 results. Ah, yes. So that's another really nice thing about having the null object pattern. All right, what's next? So we've got to make sure that that slidable module is included in, what is it? It's also part of pawn. It's also part of knight. Okay, so all of our pieces should have a module. So we've got bishop, king, knight, pawn, queen, rook. Great. So now we should be able to at least get the available moves. Now what's interesting is we need to figure out, in fact, like we're only finding the possible moves, or yeah, so this is including which moves are going to work for taking an enemy. And so I think that's a good place to stop. We do need to come back and work on pawn. Pawn is surprisingly challenging, right? Because a pawn can move diagonally, but only if there is an opponent there. And so we need to update our available moves maybe, or even our move directions, depending on whether or not there's an enemy in a diagonal position. We also need to like be able to move 2 spaces if we're on our first step versus several spaces otherwise. So we'll come back and we'll mess around with pawn in the next episode, potentially. Otherwise, I think we're going to leave it there. Thanks so much for watching. I really appreciate it. And we'll see you in the next one.